2.8. So last time we starting for one-to-one function, and we stop up to the inverse function. So 212, the inverse function. So let me remind you the inverse function. So let f be one-to-one function. So my function is one-to-one. This is mean every element in the domain takes different element in the range. Okay. So let f be one-to-one function. The inverse function f inverse defined as if y equal f of x, we can connect it as f inverse of this y is equal x. The important things here, this is a web-assigned question, the function must be one-to-one function. If the function is not one-to-one, we cannot find the inverse for the function. This is important condition. The function must be one-to-one to find the inverse. And I gave example last time, and I stopped onto cancellation property. So the cancellation properties says so let f be one-to-one function. This is mean one-to-one function. The inverse function g, suppose my inverse function is g. Satisfies f circle g of x. This is equal f of g of x equal x. This is the first property. Second one, if g circle f of x equal g of f of x, this is equal x. If in the both f circle g, they give me x, and g circle f, they give me x, this is mean the both function f and g, both of them are inverse to each other. This is also a question we will assign to check if this function is inverse. Just use this property, f circle g if they give me x, g circle f if they give me x. This means f and g, both of them are inverse to each other. So let me give you the example here now. Show that f of x equal x3 and g of x equal x to the 1 over 3 inverse of each other. Jose, yes, Jose, you are unmute. Okay, how can I show this function and this function are inverse to each other? So again, by using the cancellation property, f circle g of x, if they give me x, and g of circle f of x, they give me x, this means both of these two functions, f and g, are inverse to each other. Let's do it. F circle g of x, give me f of g of x. Give me f, comma. What is g of x?
X to the 1/3.
Yes, thanks. Now, I plug this one inside f of x. What I get?
Just x.
Yes, just x. Why? Because x to the 1 over 3, everything to the 3 is the same as x to the 3 over 3. Because here the power 1 over 3 multiplied by 3 over 3, and this is giving me x to the 1, and this is equal x. So the first one is satisfied. The second one, g circle f of x. G of f of x. Now you plug the f of x inside g. What is f of x? This is the function, x cubed. Now we plug x cubed inside this function, g of x. X cubed to the 1 over 3, 1/3. Same things, we multiply the two exponent, I get x to the 3 over 3. And they give me x to the 1, and this is equal x. And also the second property are satisfied, they give me x. Because the first one and the second one, they give me x, and they give me x, this is mean the function f and the function g are inverse to each other. So the function f and g are inverse each other. Make sense? Any question? Is it clear here?
Yes.
Okay.
Are there any circumstances where f of g of x would be x, but g of f of x would not be x? Like, can it be, do you know what I mean?
What do you mean?
Are there any instances where it's asymmetrical? Or are
Here?
inverse functions always transferable like that?
Inverse function always transferred like that. Always.
Okay. So that was a weird question, but thank you.
Yeah. F circle G always x if you have to check the two condition. First condition, F circle G. Second condition, G circle F. If both of them they give me x, this is mean both of the function are inverse to each other. If one give me x and the second one doesn't give me x, this mean not inverse to each other. Must the answer for the first one x, the answer for the second one x.
Okay, thank you.
No problem. Now, how to find the inverse function? So now we check this. If I give you two function, I tell you check this is our inverse to each other by using cancellation property. Now, I'm going to give you a function such that this function is 1-to-1, and I ask you to find the inverse for this function. So finding the inverse of a function. So I give you by step. The first step is write y as of f of x. Second step, solve for x in term of y. 3, interchange x and y, and put y as f of x inverse. I'll give you example, and we're going to follow these steps. So the example is find the inverse of a function f of x equal 3x minus 2. By the way, this function is one-to-one. Why? Because it's linear. This function is a linear, so it's one-to-one function. This is mean we can find the inverse for this function. So first step, write y equal f of x. So instead of f of x, we're going to write it as y. So y equal 3x minus 2. This is the first step. Solve for x in term of y. So this is mean we have to solve it. I have to make the equation x equal whatever, x equal the equation. Okay. So 2, how can I solve it in term of for x in term of y? By adding 2 for both sides, then I divide by 3. So actually I add 2, I get y plus 2 equal 3x. Then I multiply all these by the reciprocal for x by 1 over 3. We change different color. So I multiply both of sides of 1 over 3 and here by 1 over 3. Yes, Angel, that's true. So now I get, here's second step. Now I get 1 over 3 because I distribute the 1 over 3 inside the parentheses. 1 over 3y plus 2 over 3. Here 1 over 3 and 3, they cancel each other, I get x. So I change this one, so I can write it as x equal 1 over 3 y plus 2 over 3. I move x to this side, I move everything to this side. Now for the last step, so right now I finish second step, I solve it for x in term of y. Now interchange x and y and put y equal f inverse of x. So instead of x, I have to write f inverse of x. Instead of y, I have to write x. So third step here, x become f inverse of x. Here put x equal, sorry. Here put x
Does that make the domain and range switch places? Is that what you do?
Yes, exactly. I'm going to talk about this one.
Thank you.
The domain, let me finish first of all the
word.
Yeah. So here f of inverse of x equal now 1 over 3 x plus 2 over 3. So this is the inverse function. Now, the domain of this function f of x, the domain of f of x is equal exactly the range for f inverse of x. And the range of the function f of x is exactly the domain for f inverse of x. This is important notation. I talked about this one last time, but by this example, we can see the domain is the range, the range is the domain for inverse. Any question so far? Is it clear? So follow this step 1, 2, 3. So you can find any inverse function. Okay. Now, how to graph the inverse function? Also, we have to learn how to graph the inverse function. Graph the inverse function. So you have to know the graph of the inverse function f inverse is come from by reflecting the graph of the original function f by the line y equal x. We don't have to use like formula here. We don't have to do anything. Just reflect around the line y equal x. So the graph of the inverse function f inverse is obtained by reflecting by reflecting the graph of the function f in the line y equal x. Okay, so what does that mean? Let me do it let me explain that by the Cartesian plane. So this is the Cartesian plane, for example, and my graph is something like that. Like, let me use different color. like for example, blue color. My graph something like this. This graph is the function f of x. If the question asks me to graph the function f inverse of x, you have to do only one thing. You have to do the line, draw the line y equal x. The line y equal x is this. We use different color. This color. This is the y equal x. This is my mirror. Then you have to reflect the blue curve around this curve, y equal x. This y equal x. Reflect every point around this mirror. This is my mirror. So for example, the distance from here to here. For example, the distance from here to here. We have to draw another one, the same distance from here, same distance, like to here. So this point reflected around this, reflected here. This point reflected like around here. This point, like the graph be something like that, then it goes up again. The distance here, same as the distance here. And the same things here. The distance here is the same. Same distance, like for this. Okay. So this point here, here. Okay. This is what I mean of the how to graph any. The pink one is the f inverse of x. The blue one is the original function. Before I give you example, let me give you notation, important notation. F inverse of x is not the same as 1 over f of x. This is not true. Okay, this is not right. But f inverse f of x, everything inverse, is the same as f inverse of x is not the same as 1 over f of x. But f of x, everything inverse, is the same as 1 over f of x. You have to know these things. Okay. Is it clear, this graph? Any question? Okay, let me give an example. The example is graph the function f of x equals the square root of x minus 2. Then find, after you graph this function, find the equation of f inverse of x, b graph sketch. Graph f inverse of x. So graphing the function, how we can graph? By using the transformation 2.6. So first of all, we have to know the original function for this one. So as we learned before, the original function is the square root of x. This is the original function. And we know how to graph this function.
-2.
This is the original function. Now, the function we need to graph it is f of x equals square root of x minus 2. So this is mean. What is the mean of minus 2, William?
It'll move the
original one to the
origin two units to the right, I think.
Yes, exactly. We move this function 2 units to the right. This is the mean of, this is the graph of f of x. So here is the graph for the original one. Hold on. So we know how to graph the square root of x. It's gonna be like something like that. No, something like that. This is the original function. This is OX. Now, f of x, we draw the original one and we shift it 2 units to the right. 2 units to the right, going to be here. This is 0, this is 2, and like this. This is the function f of x. We don't need this one. Okay, so the red one is the original function. I mean like the function of x equal square root of x minus 2. So we graph this function. Now find the equation of f of inverse of x. So by using the steps here, we're going to use step 1, 2, 3. Write it, solve it in terms of y, change the variable. So my function f of x equal square root of x minus 2. We change f of x by y equals square root of x minus 2. Now, we have to solve it in terms of x. We have to square both of the sides with y squared equal x minus 2. Shift or move minus 2 to this side. I have to add 2 for both sides. So plus 2 plus 2. Now I get y squared plus 2 equal x. Or x equal y squared plus 2. This is second step. Third step, change x as f inverse of x and y as x squared plus 2. Here, because the domain, what is the domain for the original? The domain for this one is from 2 to infinity. Why? How I know this? I look to the graph. Which x value are used? The x value are used is from 2 to infinity. This is mean the domain is from 2 to infinity. So the domain here is from 2 to infinity. The 2 is including. So here, and what is the range here? The range is from 0 to infinity. The 0 is including. How I know? By looking to the graph. Which y value are used? All this y value are used. Which x value are used? All this x value are used. Starting from 2. Here starting from 0. So the range is 0 to infinity. Here the domain is 0 to from 2 to infinity. So this is mean the domain for this function will be the range for the f of x. So this is mean the domain is the range of the function is from 0 to infinity. So the domain for this function is 0 to infinity. I have to plug the 0, 1, 2, 3. I can't plug negative numbers inside this function. So now sketch the graph. I know the graph of x squared. The original function here is x squared plus 2. This means shifted up 2 units. But the domain is from 0 to infinity. You have to take the parabola from the right side only. So let me graph the second one. So the graph I'm going to use the same graph. I'm going to use the same one here. So the original function or x is x squared. So the x squared is function look like this. Now we shift this function 2 units to the up. Here is 2 units to the up. But the domain is from 0 to infinity. So the negative we don't have to use the negative. So this is mean the negative we don't have to use it. So the graph will be only this one. So this is f inverse of x that equal x squared plus 2. Any question? Anyone has a question?
If we weren't graphing it, would the inverse still only include the positive values of x in this case?
Yes. Why? Because it's the range. for the function. Another way to graph this function, how can I graph the other one? The other way is by reflecting everything around x equal y. So now I'm going to show you another way for graphing. So I have to draw the line y equal x. Now everything here, I have to reflect it around this line. The 2 here, it will be here too. This here will be here. This point is the same as this point. Okay? Yes, Angel. The inverse always the range of the original function. Yes. So again here, the domain of the function is the same as the range of the function. The range of the function is the same as the domain of the inverse. So it's the same things here. The domain is the same as the range. Same. Okay. The other way for sketching the graph of inverse by drawing the line y equal x, and I reflect every point here around this line. So the reflecting for 2 and 0 is 0 and 2. This point will be here. This point reflecting is here. Then we draw the line. Okay. Any question? Okay, no questions. Is it clear how to find the inverse? How to sketch the inverse? Okay, let's now go. So the section is finished up to here. Now let's go to the new chapter 3.1, the quadratic function. So 3.1, quadratic function. What is the meaning of the quadratic functions? So the quadratic functions is a function of the form f of x equal a x squared plus bx plus c such that a not equal 0. Here a must be not equal 0. A not equal 0. This a. So the function of the form f of x equal ax squared plus bx plus c and a not equal 0 is a quadratic function. Or if I can like define it in a different way, I can say it is a polynomial function of degree 2, because this is polynomial function. This is a polynomial function. So now when you see a quadratic function, you have to know it's a function of the form ax squared plus bx plus c. Now, we have to learn here in this section how to graph the quadratic function. But before we starting how to graph, I give you example for a quadratic function. For example, f of x equal 3x squared plus 7x plus, for example, 4. This is a quadratic function. Why? Because the variable here have the degree of the largest leading variable is 2, and this is mean it's a quadratic function. The 2 is important in the form, in the function, to be quadratic. The exponent must be 2. If there is no 2 in this form, this is mean it's not a quadratic function. That's why I said here a must be not equal 0. So now let's go to the graph, quadratic function. Before we go to the graph, I'm going to explain how we can find the graph by changing the quadratic function or write the quadratic function on the standard form. What does that mean? This is mean any quadratic function so any quadratic function f of x equal ax squared plus bx plus c such that a not equal 0 can be written of the form f of x equal a times x minus h squared plus k. So look, any quadratic function, look this quadratic, I can write this quadratic as the form f of x equal a times x minus h squared plus k. This form is called the standard form. This is called the standard form. This is called standard form. Okay.
When we complete while completing the square, right?
What's your question?
We does that when we are doing completing the square.
Yes, we have to complete the square here to find this part of the equation. Here, I'm going to give you example and I'm going to show you how we can find the standard form. How can any quadratic function like this, we can change it to something like that. But let me first explain what is A, what is H, what is K. So first things we have to know, the graph of the function is a parabola. So the graph of the function, this one, is a parabola, such that the vertex of the parabola we have to know here is h comma k. What is h? This one. What is k? This k. H and k is the vertex of the parabola. Now, is the parabola open upward or downward? It depends on A. what is the value for a? So here I have to say if a, this a I mean, if a is a positive number, the parabola opens upward. So the parabola opens upward like this, like U. Okay, and also, and the function has minimum value. So by A, I can find the how is the parabola is open. If A is positive, is open upward, and the function in the same time has a minimum value, is f of h equal k. So this is for A is greater than 0, positive. This means the parabola is open upward. This is the most important things. Second thing is the function has a minimum value. What is the value? Is f of h equal k. Now, if this a is negative, the parabola opens downward. What is the mean of downward? Like something like that. And the function itself has maximum value. Maximum value. What is the value? Is f of h equal k. So again, the important things here, a is negative, the parabola open downward, the function has a maximum value. What is the value? Is the vertex, fh equal k. It makes sense? Is it clear? Any question for these things? I'm going to give you example to explain more. Anyone has a question so far? Okay. So again, this is two important rules. Number 1 and number 2, very important. Okay, let's do an example now. Before I do the example, let me do a graph to show you exactly what I mean for the first one and second one. So for the first one here, and this is for the second one here, port here. So I have the xy coordinate, and the parabola is upward, something like that. not nice. Now it's good. So this is f of x equal a x minus h plus k. Here a is greater than 0. This point is local minimum point. For the second one, suppose my graph this parabola, here g of x is equal a times x minus h plus k square. Here a is negative, and this is like the local maximum point. Here local. So this is local minimum point. Okay. Now, sorry. So let me give you an example. By the way, this is h here, and this is k. This is h, this is k. Consider the function f of x equal 5x squared minus 30x plus 49. Okay, so consider the function is f of x equal 5x squared minus 30x plus 49. First one, express f in the standard form. Number two, find the vertex and y-intercept. Number three, sketch the graph of f. Four, find the domain and the range. F. 5, Find the minimum or maximum value of f. Or maximum value of f. Okay, let's do the first one. Let's do it together. Because this is the new things, I'm going to explain how to find the standard form. First of all, the standard form, this is mean I have to write this function f of x as the form f of x equal a times x minus number is h square plus k. This is the mean of the standard form. How can I write this one in standard form? I'm going by step by step. So first of all, you have to write the function f of x equal as 5x square minus 30x plus 49. Now, second step, you have to take the first two terms and you try to factor the first factor of for 5 for the first two terms. Why? Because we're going to make the coefficient of x squared is 1. So the first step here, I have to factor for 5, so I get 5 times x squared minus 6x. This is goes down, plus 49. So I'm taking the first step, this, and I factor it by 5. Okay? Now, I have to complete the square for this parentheses. I have to complete the square for this parentheses by adding, I have to add b over 2 square, and in the same time outside, this is inside. Let me choose different color. So inside, I have to add, inside the parentheses, I have to add b over 2a square, and outside the parentheses, I have to subtract b over 2a square, and I have to multiply by this number times 5. So inside the parentheses, I have to add this value. Outside the parentheses, I have to add this value, subtract this value. Let's do it. What is b over 2a? What is the b over 2a? b is 6, a is 1 here. What is the value? So let me do it here. b over 2a is minus 3. Let me check knowing b over 2a square. b here is minus 6 over 2 times a, 2 times 1 is 2, square is minus 3, that's true, but we have to square it. So this is equal minus 6 over 2 is minus 3, square is 9. So actually we have to add 9. We have to subtract 9 times 5. Make sense? Clear up to here? So this is equal 5 x square minus 6x plus 9 inside the parentheses. Now outside the parentheses, 49 minus 5 times 9. 9 times 5. So what I get now? Let me simplify this one. Get 5. Now, inside the parentheses, x squared minus 6x plus 9, I can find I have to factor these things. What is the factor? X minus 3. Thank you, Angel. The factor for x squared minus 6x plus 9 is x minus 3 squared plus 49 minus 9 times 5 is 45. 49 minus 45 is 4. So now I get the standard form. This is the standard form for the first part. So the standard form is 5 times x minus 3 everything squared plus 9 plus 4. Do it fast. I'm going to do it again fast. Again, the first step, I have to look into the first two terms. Now I have to factor of 5 because I need the coefficient for x squared is 1. So 5 times x squared minus 6x because the factor of 30 is 6x. And I keep this as outside. Now I have to add and subtract. I have to add inside the parentheses b over 2a squared, and outside the parentheses I have to subtract b over 2a squared times this number 5. So after I did that, because this number is 9 after I check it here, they give me 5 times x squared minus 6x plus 9 plus 49 minus, here is 9 times 5, and 9 times 5 is 45. So 49 minus 45 is 4. And now here I factor it. The factor for x squared minus 6x plus 9 is x minus 3 everything squared. Now everything here is the standard form for the first equation of x equal a times x minus h squared plus k. Any question so far? Any question for the first one, standard form? So now what is a? This is my a. This is a. This is my h. This is my k from the formula here. This is my k. This is my h. This is my a. So I can write it here, a equal 5, positive number, h equal 3, k equal 4. Now second step, find the vertex and the y-intercept. How can I find the vertex? By using this property. Any quadratic function of x equal this can be written as of the form this. So the graph of the function is a parabola with a vertex. This is the vertex. H, comma, k. This is the vertex. H, comma, k. Thank you, knowing. So for the second part of the question, the vertex is h, comma, k, and this is equal 3, comma, 4. Why? H is 3 and k is 4. Now for the second part, find the y-intercept. How can I find the y-intercept? By setting x equals 0. I have to plug x equals 0. So the y-intercept by setting x equals 0. So plug the 0 inside this equation. F of 0 equal 5 times 0 square minus 30 times 0 plus 49. So 5 times 0 is 0, 30 times 0 is 0, the only left is 49. So I can use this equation or this one. Both of them are right. I can use this one to plug the 0, or I can use this one to plug the 0. And both of them, they give me the same answer. But I'm choosing this one because it's easier to plug the 0 here. So by setting x equals 0, so f of x equal 5x squared minus 30x plus 49, plug the 0, f of 0 equal 49. And this is the y-intercept. So I find the vertex, I find the y-intercept. Is it clear up to here? Any question? Now the third one, sketch the graph of f. So to sketch the graph, I have to know what is A. If A is positive, the parabola opens upward. If the A is negative, the parabola opens downward. So here, A is 5. A is 5. This is mean is positive. This is mean the parabola will be open upward, something like that. So let me do the third one. Third one. So first of all, to do the third one, I need a vertex. The vertex here is given from the first part, is 3 and 4. So here the vertex is 3, 4. Second thing is the y-intercept is given is 0, 49. Y at 0 is 49. So this is mean when I graph the function, the vertex is 3 and 5. So this is 3 and 5. 1, 2, 3, and 4. I'm sorry. 1, 2, 3, 4. So the point like around here, this is the vertex. A here is positive. A equal 5. This is mean positive, upward. So now let's graph it. So at 3, 4 vertex, here the vertex around here, and the intercept at 0 and 49. This is mean, let me shift everything down. Shift it down. So this is 1, 2, 3, 1, 2, 3, 4. So the graph, like here is the vertex, and it is parabola upward, something like that. Here, it's intersect at the number 49. So This point here is 49. This point here is 3, 4. This function is f of x. This is x-axis, y-axis. Any questions so far for this one? Third part? Any questions so far for the third part? How to graph? So to graph, I need vertex, the y-intercept, and A. Fourth part, find the domain and the range of f. So the domain and the range for the function f, I can find it from the third part, from the graph. So what is the domain here? What is the x value are using? What is the domain? Which value of x are used to graph the function? We're using everything. Look, we're using all this point. This means the domain is the real number r. Okay? And what is the range? What is the range? Which y value are used to graph the function?
Y is greater than 4.
Yes, exactly. Y greater than 4. Because at this point, we're starting from here, and all the points here are used. So you can set y such that y is greater than or equal 4, because the 4 are used. This is the range. Or I can set from 4 to infinity. Any question? So number 4 is the domain is R. The range is from 4 to infinity. Number 5, find the minimum or the maximum. To check the minimum or the maximum, we have to go back to the A. If A is positive, the function has minimum value. If A is negative, the function has maximum value. My A here is positive. So this is mean the function has a minimum value. Positive, minimum value. So number 5, A is equal 5 greater than 0. So the function has a minimum value. And what is it? The minimum value is f of h equal k. F of h equal k is f of h equal k. H from here is 3 equal k is 4. So is f of 3 equal 4. Any questions so far for this example? So if you understand this example, you can do any question in WebAssign. If if you understand this example, you can do any question with a sign. Domain, range, standard form, and the minimum and the maximum value. Is it clear?
Yes.
Okay. So after this example, now we can find the maximum and the minimum value without doing the standard form. Like for example, if I give you example like that, find a function that, and I told you what's the minimum or the maximum value, you don't have to find h and k and to find the standard form. You can find it directly. Like for example 5 here, find the minimum or the maximum value. To find this, we go back to h and k, to the standard form. Now we're going to learn something new, how to find the minimum or the maximum value without going back to the standard form. So finding here, finding the max minimum value from the quadratic function. Directly. So how is the way? So here is the step. The maximum or minimum value for quadratic equation quadratic function, sorry, always happened at a point x. This x, the quadratic function here, f of x equal ax square plus bx plus c, and a not equal 0. So x here is minus b over 2a. So if a is positive, the function has a minimum value I mean for a, this a, the function has minimum value is f of this point minus b over 2a. If a is negative, the function has maximum value is f of this point. So actually you have to check a, if a is positive or if a is negative. You don't have to make a standard form. This a, I mean. So again, suppose I have a quadratic function, then to find the maximum or the minimum, I have to first find x equal minus b over 2a. Then I have to check A. If this A is positive, the function has minimum value. If this A is negative, the function has a maximum value. What is the value? Is f of x, f of this point, f of b minus b over 2a. Example for that. Yeah, sure. So, okay. So the example now, find the maximum or minimum value for f of x equal x squared plus 4x. You don't have to make the standard form. Just you have to check what is A. What is A here?
1.
Is 1. This is my A. The coefficient of x squared is 1. This is the first step. Is it positive or negative? Is positive. 1 is positive number. This is mean the function has minimum value. The function f of x has minimum value. Why? How I know? Because A is positive. Go back. A is positive, the function has minimum value. A is 1, positive number, the function f of x has minimum value. What is the value? So the value is f of b, minus b over 2a. What is the minus b? What is minus b? By the way, this is a, this is b.
That would be negative
What is,
4.
yes, thank you. Negative 4 over what? Over 2a. This is my a, 1. 2 times 1. Get f of negative 4 over 2 is negative 2. Now, I plug this number inside this function. F of minus 2 equal minus 2 squared, inside the function here, plus 4 times negative 2. Minus 2 squared is 4, plus 4 times negative 2 is negative 8, right? So not minus 8, I get minus 4. That's it, done. So we don't have to find the standard form, we don't have to do all these long steps. Any question? So let's go to the 3.2 polynomial function. We have 10 minutes. Let me give you just the definition. So 3.2 is polynomial function and their graph. So first of all, what is the meaning of polynomial? Let me define the definition, give you the definition of polynomial function. What does that mean? This is mean is a function the polynomial function is a polynomial polynomial of degree n is a function of the form bx equal a n x n plus a n minus 1 x n minus 1 plus a1 x plus a0. This one an and this one an minus 1 and a1 and a0, all of these are called coefficient. This is coefficient a0, a1, an minus 1, an, all of them called coefficient. This term here, this is called leading coefficient. Leading coefficient. And this one is called constant coefficient. This is just definition. You have to know the name because during this class I'm going to say leading coefficient. You have to know you have a you have to get a knowledge what's the meaning of leading coefficient. The leading coefficient, this is an, is connected to the variable, to the exponent, the greatest exponent n. Second things we have to know in this section, how to graph the basic polynomial function. For example, like if I have polynomial, so for example I give you the graph of some polynomial functions. This one, number 2, number 3. So here graphing basic polynomial function. Like for example, the line y equal x y equal x. This is a polynomial function. This is a line. The slope here is 1. So the graph for this function is gonna be like something like that. Y equal x is a line with the slope 1. So this is y equal x. Now for y equal x square is a parabola. The graph is gonna be something like that. Something like this. Parabola. This is a quadratic, as we learned in the previous section. Now, for y equal x to the 4, look, any even number 2, 4, all of them have the same shape. But around the 0, it will be like more open. Look around the 0, like something like that. Okay? Y equal x squared, y equal x4, y equal x to the 6, 8, 10, all of them have the same shape. Parabola. What about y equal x to the 3, the odd number? So the odd number, graph the odd number would be something like that. This is y equal x to the power 3, and this is y equal x to the power 5. The graph for this one would be something like that. The graph for this one, around the 0 will be like more open, like something like that. Here, something like that. Okay? So this one, second one, third one, fourth, fifth. You have to know the graph for this basic graphs. Okay? Now I'm going to stop up to here. Next time I'm going to go over the end behavior for how to graph for the polynomial. Have a good night, everyone.
Thank you, Professor.